Today's problem from maximum minimum, and it is said that this is a problem of function of several variable or multivariate calculus, and the problem is if xyz this is equal to a square into x plus y plus z, the minimum value of yz plus zx plus xy is given by 9 square. We have to find the value of this minimum value of this is proof that 9 square. Okay, here we use to find the minimum value of this expression, we use Lagrange method of multiplier, or it is said to be Lagrange method of undetermined coefficient. What is the Lagrange method? The summary of this method is we have to find max or min value of a function f with subject to the condition is g of xyz this is equal to 0. We first find Lagrangian or Lagrangian function which is given by L is equal to f plus lambda into g, where lambda is said to be Lagrange multiplier, right? Then we have to find first the stationary point, and stationary point is given by Lx, Ly, Lz this is equal to 0. That is the partial derivative of L with respect to x, y, z, we must be equal to 0. And now we have to find the second differential, that is d2L, and since we have to find out the minimum value, so here d2L must be greater or equal to 0, that is positive definite. Okay, we only give here for minimum value, the condition of minimum value. What is d2L? d2L is given by Lxx dx square plus Lyy dy square plus Lzz dz square. This is the second partial derivative, and this is also, and plus 2 into Lxy dx dy plus 2 into Lyz dy dz plus 2 into Lzx dz dx. Right, this is the expression of d2L. Now we start from this function. This is given by f here and this is given by g, and we write first g in the form as x plus y plus z by xyz minus 1 by a square this is equal to 0. Okay, and now we get L this is equal to yz plus zx plus xy plus lambda into this is given by 1 by xy plus 1 by yz plus 1 by zx minus 1 by a square, right? This is the Lagrangian. Now we first find the value Lx, Ly, Lz and equate all of them equal to 0, and Lx is given by Lx this is given by, from here we get z and from here we get y because this is the partial derivative with respect to x, so this is 0, plus from this term we get lambda into minus 1 by x square y, and from this term we get minus 1 by x square z, and this term is 0, also minus 1 by a square is purely constant, so this is must be 0. And if this is equal to 0 we take, then we get the result as y plus z minus lambda by x square yz into y plus z this is equal to 0. Okay, and this result gives lambda this is equal to x square yz, because here another factor we get y plus z. If we take this is equal to 0, then we cannot find the value of Lagrange multiplier, this is lambda. Okay, now in similar manner if we find Ly, then we get the value of lambda. If we find Ly and then equal to 0, we get lambda this is equal to y square xz, and similarly Lz this is equal to 0, we get lambda this is equal to z square xy. Okay, since all three are the value of lambda, so we can equate all the three terms, and getting the result as x square yz, this is equal to y square xz, this is equal to z square xy, and this gives x equal to y equal to z. Okay, now we put this value of xyz here, so we get this is x cube and the right side is 3 square x, and this gives x square, this is equal to 3 square, so we get x, this is equal to plus minus a root 3, right? And since all are equal, so we get x equal to y equal to z, this is equal to plus minus a root 3. If we take plus, then all of them are plus. If we take minus, then all of them are minus, right? Now we have to find d2l. What is d2l? d2l is given by, from here we find lxx, and this is given by, this term is 0 obviously, and from the second term this is lambda into d2x, this with respect to x again, so we get this is 2 by x cube y plus 2 by x cube z into dx whole square. And similarly, if we find Lyy dy square, then we get the value as plus lambda into 2 by yqx plus 2 by yqz dy square, right? This is dy square, and third term is 2 by zqx plus 2 by zqy dz square. Now this term is given by, if we differentiate Lx with respect to y again, we get the result as 2 into, this is 1 because the derivative of z with respect to y is 0, the derivative of y with respect to y is 1, and from here we get this is plus lambda into 1 by x square y square. Okay, because this is the derivative with respect to y, so this term is 0 and the derivative of 1 by x square y is this. And similar manner we write here dx dy first, and similar manner we get 2 into 1 plus lambda into 1 by y square z square, this is dz dx, and plus 2 into 1 plus lambda into 1 by x square z square, this is dz dx, sorry, this is dz dy or dy dz, right? dy dz. And clearly if we put x, y, z, this is equal to a root 3, a root 3, a root 3. We clearly get from this value, that is at this value of x, y, z, we get d2l greater equal to 0. Okay, so at that point the function must be minimum by the condition of theorem Lagrange multiplier. Okay, and the minimum value is given by putting the value of x, y, z, this is equal to this from here we get. So minimum value, so mean value of f, this is equal to xy plus yz plus zx is equal to, we put the value of x, y, z are this, we get this is 3 square plus 3 square plus 3 square, this is 9 square. Okay, and we want to prove the minimum value of this is 9 square, and this is the proof. Okay, so this is the complete proof of this problem. Very important type of problem. Thank you for watching.